All right, guys, let's get started. So today is the last lecture. Right? So, all right. Yeah. So the plan. I'm gonna look at the calendar. I guess. Let's take a look at that first. Graded your exams. I want to say. I'm finishing up all grading. Hopefully this week. All right. So yeah, let's take a look at the calendar. I believe I need to share this screen also. All right, anyway. So let's look at the course. So in the calendar, you can see what today is April 19th. So we are going to cover the last set of topics, which are file system analysis, and then Docker. I'm going to give just a brief intro to Docker, okay? Certainly a tool that will become really important in your IT lives, right? You're going to be using this a lot. It's my belief, actually. So we're going to do an intro to it, very brief. We'll work through an example. But yeah, so the plan, and I guess I should start the recording also. It is recording. Okay. So today we're doing this file system analysis. There is a bonus homework here, so I'll discuss it, but it's not required at this point. So if you want to do bonus points, you can do this assignment. I'll talk about it basically, and that's about it. All this has to do with the file system. And then, as I said, Docker as a tool. April 21st, I would like to see your projects. Remember, you need to come to class just so that I can kind of see what you're going to be demoing, both for Project A and Project B. And then presentations are going to start April 26th. Okay. On this day, you have to do your presentations. And I always say the 28th, this is a fairly large class. So usually, not everyone will be able to present on this day. Also, if something fails, you have a second opportunity to demo. Remember, you must demo everything, right? So that's the whole point of this, that you can, in live environment. Yes. Yeah. Yeah. Anything that you want to do on Linux that wasn't a topic this semester. So there's a lot of things. So some people are doing like their own GitHub. Other people are doing email servers, right? So we've talked about this several times. Anything else? All right. Yeah, so that's the plan. So presentations will start next Monday or next Tuesday, sorry. Today, as I said, is the last lecture. So I'll just cover some of these topics. So I'll start with, and then I guess before I get started, are there any questions? Okay, so if you don't have any questions, just mute your microphones, please. All right, so let's start talking about Docker, actually, and then we're going to talk about the file system. So what is Docker, basically? So let me think. For this, I should probably connect my. So anyone know what Docker is? Anyone can tell me a little bit about it? No idea. Yeah, go ahead. No. A container system? Kind of similar, huh? Yeah, yeah, yeah. So yeah, good answer actually. So I would say it's a good answer. So let's go. As I said, it's actually an extremely important thing. As with everything in technology, we're always, I mean, I myself, I'm like always 2 years behind. That's just the reality of it. And so, you know, I can tell you that much with Docker. It's becoming more and more important. Okay. So as Noah said, it's, you know, you can, whenever you think about Docker, you can think of virtual machines, but it's actually not the same thing at all. So what's the main complaint that you guys have related to your VMs? What's the one thing that's like, you know, the size of it, right? They're too big. They consume too many of your resources, too much of your RAM, etc. Right? So Docker takes care of that. It's a much, much lighter footprint, okay? And so that's an important thing. So if you use Docker, for instance, you're not going to be consuming as much memory. But it's not just for that. It's not, you know, Docker is not just like, okay, it's just a lightweight VM. It's not that at all. It's actually, you know, it's this idea of containers, right? Containerizing. So basically, the problem comes in like this. Let's say that you were, you know, and I'm sharing the white screen here, you were a software developer, right? And let's say you're a data scientist, something like that, right? And you write code, right? You write Python and you write, you know, other languages like that. And what happens, what have we learned, for instance, with Python all semester? We've learned that we always have to install libraries, right? So every time we want to do anything, we install a whole bunch of libraries, a whole bunch of dependencies. You know, I think I talked a little bit about virtual environments in Anaconda, for instance, right? At some point, I must have mentioned that. And so usually what you do is you create an environment on your local machine, and then you set up a whole bunch of dependencies, and then it runs on your VM. Or sorry, not on your VM, on your server, right? So it runs, you know, you spend a lot of time configuring this machine. Maybe it's an AWS instance, whatever it is, right? You know, and you know, this works for both Windows and Linux, but you know, this is a course just on Linux, so a lot of the focus will be on Linux. Okay. All right. So the idea is what? The software developer builds all the dependencies, etc., and they have everything working nicely, and then they start running the code and it works great. Okay. Then comes another developer, and then they want to run this on their own machine, a separate machine. So they find some way, you know, they get a copy maybe from GitHub, something like that. And what happens? It doesn't work. Something is wrong. Maybe there's a different something, some setting is different here, right? And now the thing just doesn't run. And so you have to spend all that time configuring it and figuring it out. And then guess what? At the end of the day, you have two implementations of it, and they're slightly different somehow. You guys see that? And then comes a third one, and the third one wants to do the same, and you know, and it's an endless process, right? So containers are the idea that, you know, how do you address this issue? And so the idea came that you would use something like Docker, where you create a container, and then this container, there's a hub, you know, on the internet, like a website, you know, docker.com. And so you can add the containers there, and then everyone, I'm going to use a different color here, everyone now can just get it from the hub. Do you guys see that? And it's going to be the same thing, the same unit. It's basically just software, right? That's going to run. What's great about it is it's not like you have to download a virtual machine. As long as you all have Linux, let's say that this is Linux, and then this is Linux, and then this is Linux, right? So you don't have to download a VM that's Linux. You're just going to use that host's OS. You're basically going to share the resources. And that's why this becomes efficient, right? Much better than a VM. With a VM, you would have to get the VM and then, you know, get all that going. But here you can just download the container. And as long as you're using, let's say, like an actual Linux, it'll run on there. easily. Now, you can also take, let's say, the scenario of Windows, and you can take a container that's Linux, and then what's going to happen is there you will have to have a VM, but that's still going to be lightweight in a sense. So you can just put the container, so that it would be the container, right? And then the VM, which is Linux, and then running on top of Windows. So that's a way to do it, but this is not really, I guess, what you would want. If you're looking for efficiency, what you really want to do is you want to have a Linux host, that's running in like the background. The kernel is Linux, and then of course there's going to be Docker, right? So Docker is going to be the environment that allows you then to bring in all these containers. Do you guys see that? And that's the idea. Okay, so it's that. I mean, that's really the idea there. So the advantage, it's very lightweight, and you can move the software basically, and you don't have to really install the dependencies. You can just say, for instance, oh, I want a web server running MySQL. So guess what? You just go in, you create the container for it, the Docker container, and then you make it available. And then anyone that wants to use it can download the container as long as you have Docker installed, and then you have it. And you don't have to do any other configuration, but at the same time, you can add things, obviously, if you wanted to, etc. Does that make sense, guys? And that's the general idea of Docker. And the advantage of it, as I said, is that it's much more lightweight than virtual machines. Okay, so certainly something to consider as you go forward in your task. So today, what we're going to do is we're just going to do some examples of the commands and everything. If you have a Mac or a Windows, you can install this from docker.com. So I'll show you where you guys can go to get it. But if you're using the seed VM, Docker is already installed. So then we're just going to use the Docker instance provided in the seed VM. All right, so let's go ahead and there's other tools like Kubernetes, et cetera, which are a little bit more on top of Docker, even more advanced concepts. But for now, we just need to understand that. So basically, it's kind of, you can think of Docker. Let me just say a couple of things about it, I guess, before we start with the commands. One of them is basically, so Docker, it's a way to create a container of software, right? So the idea is for software development, that you can carry basically. And then the other idea is a little bit of virtualization. But much more efficient and with a smaller footprint, okay? So it's got a smaller footprint. The things that will be involved when you're talking about Docker are going to be, there's going to be something called a Docker file. So the Docker file, there's going to be the Docker program itself. And then from there, we can create containers, which are the individual things that we can share. We can, you can put up your containers on the Docker Hub, or you can just share them, and so that's the main idea. All right, so let's go ahead then now and play around with the commands for Docker a little bit, just to get a feel for how it is. That's probably the best way to try to understand it. Let's go. I'm going to start the VM. So we're going to use the seed VM, which already has Docker, but I guess let's go to Docker. Right, so this is the Docker website. Okay, you can, if you want to start reading through it, if you want to install this on your own machine, right, you can follow the instructions, get started, basically download and install, and everything else. And so you'll be able to set it up. Okay. So let's go to yeah, go ahead. Huh? Oh, yeah, I'm sorry. I forgot. Yeah, so sorry about that. Right, so if you want to go to the Docker site, here it is. So docker.com. It's got that little whale with the little containers on the top, right? So that's the basic idea. So it's Docker is kind of that environment that allows you to have all these different things. All right, so let's go ahead and now switch over to the virtual machine and just start it up. So I'm going to start the VM. Now remember, I'm using the VM. This could be Linux, right? So here it's really not an issue. As this is not about virtual machines per se, this can run natively on physical Linux. So my goal is we're going to look at some of the commands, kind of play with it a little bit, and then after that, we're going to build one or two simple applications for it. All right, so let's log in. I'm going to share the screen for the VM now. All right, so everyone should be seeing the VM. So let's take a look. Let's start up the terminal. And since I'm going to create some files, I'm just going to navigate to the folder for the course semester. So navigate to the desktop. And I have a folder there. You can see Docker files. I created just now. So I suggest you create one. So we're going to create, let's just create a file here. I'm going to call it like in class, right? And just kind of to make directory in class. And this is just where I can create some files. Okay, so we're going to think about the logic. Now, Docker is already installed on the CVM, so you can just type Docker here, and you can see that it runs, and there it gives you all the output so that you know that the program is there. So that all I did is I typed Docker. Okay. And so that's the first thing that we want to take a look at. We can also do sudo docker version, and then this gives us that we are using the 20 version. So it's the latest, probably one of the latest, and then it gives you some information about the things that are available here. Now there's a lot of, it's really neat, right? So there's a lot of containers already out there on the internet, right? So and so in a second, I'll probably look for one just to kind of give you an idea of how that could work. We're going to go, instead of going to the docs.docker.com, this time around, we are going to go to the hub.docker.com. And usually this has become very common nowadays, at least for me in the last 2-3 years, that hubs for software itself, shareable software, right? So this is very common. Docker, for instance, is important. There's also, this is used a lot by web developers, for instance, to share their web servers, etc. Literally all of you could have done your project, for instance, on Docker, literally. and then share it on the Docker hub if you want it. That's entirely something that you can do. It's not really that difficult. So today I'm just going to do like a very generic and very simple explanation of how that would work. But yeah, you know, in AI and machine learning, you also see this a lot. Everyone's creating models now, and then they share them on the web. And I don't know. I mean, it's software, shareable software has become a thing, and in specific software for specific tasks. So if you guys solve the problem, a specific problem, you can create the Docker container for it, share it, and then other people can just like literally use that to solve whatever that problem is. All right, so let's go ahead then. So everyone should be seeing the VM now. So let's go to the hub first. So I'm just going to open up the browser here. Okay, and we are going to navigate to hub.docker.com. All right, so you can see that there. That's the hub. Build and ship any application anywhere, right? So that's their slogan. Although this is really great and everything, Docker, I don't know that they're a publicly traded company. The last time I checked, they hadn't really found a way to make a lot of money, right? So they're, you know, even though they have a nice model, you know, but it's important, right? So there's obviously something there. I think they just haven't found just yet how to profit from this excessively. I mean, like nowadays. But anyway, you can see here, Docker Hub is the world's largest library of and community for container images. And this includes, you know, these are the main ones that you would want. A Node.js. So this is like, for those of you that like web development, that kind of stuff. So you can use that instead of PHP, for instance. MongoDB, and then Ubuntu, of course. Python is there, which is very big for data science. MySQL for like web applications and so on. So you can see. Now, if you're looking for a specific application, you can go here. Now, another thing that's common is that let's say that you all want to share your containers on the hub, you have to create an account. So there's going to, you know, whenever you basically have what is called like a namespace, right? Like we talked about in the Linux sense of namespaces. So all of you, you know, everybody that has an account on Docker will have a user namespace, basically. And then under that is where you're going to have all your containers that you're sharing, basically. So in this case, for instance, we're in the Docker hub, and we can search for something. So usually like the hello world of Docker is something, their theme is a whale. So they have a thing called whale say, and it's just like a little hello world just to get started. So I felt, you know, that's a good place to begin. So you can see there's whale say. So I looked for it. You can see that the main account for this is Docker. That's the namespace, obviously, for the company Docker. And so I click on it, and now you can see I have it right there. You see that? Now, then you can take a look at it. You know, this is what's going to happen. So when you do Docker run, Docker whale say, cow say, boo, then it's going to print out boo, right? So, you know, it's hello world. And that's just kind of to get started. The Docker file, if you look, is just basically like this. So we'll talk about that in a second. But so this is the name. So I just kind of want to mention this. Now, you don't actually have to come up here and download things, right? And then install them or something. You can literally just do that from the command line by typing the word Docker. And then you can see it basically, if you remember the GitHub discussion that we had on last week, you know, you can basically think of, you know, it kind of follows the same idea. You're going to pull and push, you know, various things, right? So we'll see that in a second. But kind of wanted to just start with this one. So it's, you know, by Docker. And this is an image for use in Docker demo tutorial, right? So just kind of to get us started with the idea of Docker. It has a brief description, how to use this image. So basically you just run this command. So we'll do that back in the terminal. And then there's a file associated with it. And then we're also going to create one of these little files that basically will allow us to create our own containers, right? So here you basically have a few keywords like from, run, environment, and CMD, which is the command, right? So basically what you want. So what you do is you specify just easily, you say, well, I just want a Ubuntu 14.04. That's it. Literally, that's it, right? So, and just like that, boom, you have a Ubuntu. Or you say, I want a Ubuntu 20.04, from Ubuntu. So this just means that I want this Ubuntu, and then we have a colon, and then this just specifies the version that you want, right? So Ubuntu 20.04, et cetera. You can say Python here, colon 3.8. It doesn't even care about the operating system. Remember, we're running this on Linux, right? So the idea is that if you want to be efficient, you run on a Linux environment, and then you're going to pull these Linux containers so that the resources are shared. Then you have look at here, apt-get. So you guys should be familiar with that command from Linux. What's happening here is basically all the dependencies are being installed. So just you have a file, and the file already has all the installation commands. Everything that you would type on the command line. Oh, I need this program, that program, etc. It just needs to go on the file. And then when you run this file, it'll just run everything, right? This is if you want to install a path. This is not necessary in all examples. Then you copy some code from one place to the other just to add. Let's say that you've written some code in your local environment, but now you want to move it to the container, right? So that makes sense. You make a copy of it. We'll do that in a second. And then you run, a few additional like copying things or moving things. This is actually a symbolic link that you're creating. And then finally, you just run the command that you want to run. So in this case, it could be something like Python 3, mypython.py, right? So, or, some script that you're running or whatever it is that you want to start. So it's basically the general idea is you say where you are, what type of like version of operating system software, install any additional dependencies that you might want to do, copy the program in question, because usually when you're creating a container, it's because you've created some specific code, right? And then finally, you want to say how it should start. So literally, like when somebody runs this container, boom, it's like on the command line, and it's actually running the program that you intended to be run. Okay, does that make sense, guys? And then if you want to pull it directly, you can just do something like this one over here to run the example. All right, now by default, if you're following along with your virtual machine, your Ubuntu 20.04, whale-say should be there already. So you should not need to pull it, okay? But obviously, it's not going to have everything by default. So a lot of other things from the hub, you will have to download. Now, the command for that is just docker pull, and then remember the namespace of the user that made that container available, and then the container itself, okay? And that's it. So that's kind of the idea. So let's go ahead and let's try to run whale-say and just get a feel for how it works, plus a few other commands here and there. But anyway, that is the Docker Hub, where you can actually share your containers if you want to, or download containers as necessary. All right, so let's go ahead now and let me connect the power. Okay, so we did version, right? And so now we're gonna just gonna check where I am. Docker files. Oh, wait a minute. All right, I'm gonna go into in class. All right, so now I'm going to do sudo docker run. And so I'm going to run whale say here, and it should be available. Okay, so I'm going to do sudo docker run, and then I need to specify the namespace. So that's docker, and then whale say, and then there's a command cow say. That's just their like an inside joke or something. And then there it is. So you can see here, basically, I'm able to just run a container. So that's all I'm running here. But this container, let's say that it had, many dependencies and libraries. Well, they're already there. I don't have to install them. I just run the application. You guys, yeah, go ahead.
So Calix is basically like a predefined command inside of the whale say container that you.
Yes, exactly. It's a way. It's almost like an interactive way. So a way to interact with the container. Yes, with the container. Otherwise, if you just run the container, it may just do like a default thing. But here you can actually interact with it, give it inputs basically, and get outputs. Does that make sense? Yeah. So if I do, for instance, hello world here, which is how we should start this one, right? So hello world, and there it is. So it gives different inputs basically. Did you say something? Just thinking out loud. Yeah. So this is our first example, just to kind of illustrate. So the beauty of this, as I said, is like, you may spend, many weeks installing the software, the dependencies, and then writing your code, but then you just, here it is, go use it. And as long as you have Linux, it should be not a big problem. Go ahead.
So any command inside the container has to be predefined?
Yes, it's
if it's not in the file,
right. Right. Like if I say cow say in some other thing, it's not going to work. It's not like this is very specific to this application. You kind of have, I guess you should write a README file where you say, hey, by the way, these are the commands, but something, how to use the container. But it's pretty simple and very lightweight. Any other questions? Nope. All right, so let's keep going then. So as you can see then, you've seen that, I do a clear here. The basic syntax for running Docker is just doing, I'm sharing this one. So the basic syntax for running Docker is just like Docker run, and then I'm just going to make up a name here, container, right? So just, your program, whatever it is. So that runs that specific container. You can also do Docker PS, for instance. So a lot of the commands in Linux, are kind of what they use for their own Docker flags and inputs, right? So in this case, this shows the programs that are running in Docker. So currently there is no program running in Docker itself. You see that? Now, a few other things. And now if you notice, things that are important is, in a second, I guess I'll open up two terminals so that we can run one and then see kind of the data. But a Docker container will have a container ID. It'll have some information about the image, the command, and things like created status and the name of it, etc. Okay. Let's say that you have a Docker program running and you want to stop it, then you would do Docker stop, and then you just put in the ID, basically, which you would get from underneath this. That would be the ID, very much like whenever you have a process running and you want to kill it, right? So you kill -9 that process ID, basically. All right, so the name should also work as well here. you want to see Docker images, you can type Docker images, right? And it's going to give you basically the kind of the ones that you have by default here in your program. So including, for instance, whale say, you can see that that's kind of like by default included. And because we're using the seed VM, right, we have a few additional containers which have to do with what? They have to do with the seed labs themselves. Okay, so for instance, if you do the clickjacking lab for the seed labs, you know, you can just, as you say, spin up, right? With the VMs, you can just spin up the container for the clickjacking task and then use it for whatever it is. And it'll have everything that you need, all your dependencies, you know, the database that needs to be running, etc. Does that make sense, guys? Yeah. So that's the basic idea. Now, if you wanted to remove an image, you know, I don't suggest that, I don't recommend that you do that, but you can do Docker, because these are kind of built in for your VM, but you just do RM and then the container. Okay, you know, I'm just going to put container one, right? So the RM, again, if you notice, it's basically just showing the, you know, similar Linux commands are being used here. Okay, so that's kind of the idea. Okay, so now a very simple way of just setting up, now you can create a container that is very straightforward. So just like directly on the command line, you can create one, but usually your containers are going to require, you know, more dependencies, are going to require more dependencies, etc. Right? So you're usually not going to set them up here in the command line, but we can try one. For instance, I'm going to do Docker, and then I'm going to do run. And then here I'm going to put in a couple of flags. -I means interactive, right? So it doesn't just run, but you can actually like interact with it. And then -T just means terminal. So it's going to display as a terminal, and then --name. So here we're creating one, and you can call it, you know, my first container. My first container. And then we're going to say that it should be a Ubuntu VM : and then for the version, we're just going to say latest. And that way, you know, I'll just grab the latest version of Ubuntu. And this is a really quick way of spinning up a Ubuntu environment, but, you know, it's just a simple one. And then you're going to specify the program that should run by default. So in this case, we're just going to call bin bash, right? Which is basically your term, what you get when you run a terminal. So now if I hit enter here, and this is probably because I did this earlier. And there you go. If you notice, before the prompt was cvm, right? And so that was the cvm prompt. Now notice it is root and this. So this actually means that this is another prompt, right? Not the cvm prompt. You guys see that? And very importantly, if I do who am I, for instance, notice that I am root. So here, you know, I'm not seed, or, you know, what I was before. I'm no longer technically in the seed space. I am in the Docker container that I have spun up on the seed VM. Do you guys understand? And that's the basic idea. Since I have this one running currently in the background, I'm going to open up a new window. Yeah, go ahead. Huh? Yes. Yeah, exactly. So I said, you know, run the container, but what do I run about it? Run the terminal. Yes. Usually you'll see you would run like a specific program or something. So you always can tell it what it is that you want to run. Does that make sense? All right. So let me now that we have a container running, we're going to go ahead and do Docker PS. And you can see that now I do have, in fact, a container running. It doesn't look great here. Yeah, better. So you can see this is the container ID. That's the image that I'm using. This is the command that's currently running. And then a few other information, and then the name of it, right? So this can show you all the containers that you currently have running. Now these, you can also specify them to have open ports, all kinds of things. So you can literally like spin up another Apache web server, but this one would be a more specific Apache web server, or you can literally deploy an entire website, right? An entire, whatever, e-commerce site, all within a specific container. It'll have its own Apache version, all the PHP versions that it needs, Node.js that it needs, etc. Plus, it'll have the database with all the information, etc. Got it? No questions? All right, so I'm going to exit out of here. All right, and I'm still in the other terminal. I am still in the container itself. As you can see, this is the basic space of that container. Now I'm going to go ahead and I'm going to exit out. So you can just type exit. And if you notice now, I am back to CVM over here. If I click who am I, right, I am now seed. So I am currently, now the container is basically, the instance of that container is destroyed and gone. Okay, so it's no longer running. You can also do Docker container ls, right? And it gives you information about containers as well. All right, so now we're going to go ahead and we're going to try to build our own little container using the Docker file. Okay, so that's going to be the next step. We're going to do that. All right, so what do I want to do here? I'm going to create just to keep it simple, right? I'm going to keep it very simple. I'm going to create, so if I'm going to clear this, and I want to create a container, and let's say that the container would run a Python script. I've been working on this Python script for a long time. It's a lot of code, and it needs a lot of libraries, dependencies. And then I want to share it, right? So I want people to just be able to use it, to run it, and get some results. So how do I do something like that? So, first of all, I'm going to write the Python script. So I'm just going to do nano, and this is going to be simple, obviously. And I'm going to say, I'm going to call it main.py, something like that. And then I'm going to make this executable. All right, so that it can just run executable. So I'm going to put in shebang here. So I'm going to say bin environment and then Python 3. So I can find the program, and then I'm just going to have a print statement. So I'm going to say hello world. Obviously, this can be any code that you want, and it can be as complicated as you need it to be. It can have all the imports in there. Obviously, you have to do that installation in the Docker file itself. All right, so I've created the script. So there it is, hello world. I'm going to save it. Now, as you can see, it's there, but it's not executable yet, right? So I'm just going to make it executable. So I'm going to do chmod plus x and then main.py. Right, so now if I do the ls, now the script is executable. So I should be able to run it just by typing main.py, and there it is. It runs fine. But this is still running just on the virtual environment. What I want to do is I want to containerize it, right? That's basically my idea. Now the containers get added into the Docker space, all right? So that's something that might be confusing. You might think it's like compiling a program where you compile the source code, and then you get an executable and you expect it to be in the folder. But here what you do is you really don't want that, right? You don't want to have all these executables, to so to speak, and instead you run the file, the text file that contains all the instructions. It'll create that instance via Docker, and then when you're done, it'll go away, right? But it's kind of that's the pipeline. So now we're gonna create the file that we need. We're gonna create a Docker file. So I'm gonna go ahead and do nano, and I'm gonna create a file. I'm gonna call it Docker file, right? And in this Docker file, I'm going to specify the things that, whenever I create a container, that container should be, this and that. All right, I'm gonna put it, now if you wanna add comments, you just like in Python, you use #. That's very useful, to kind of remind you of things. So in my case, I'm just gonna plug in the commands that you need to run in order to create this image of this container. So I'm gonna do Docker build, so that will be the command, -t for terminal, and then you need to give it a name when you run it, right? So in this case, when you build it. So in this case, it's going to be Python and then just, RC. So my initials. So that basically just gives it, that's the Docker object that I'm creating, and I'm calling it this. Then after I create it, and it's not running by default, it just exists. So now I want to go in and run it. So I'm going to do Docker run, and then I'm going to say, Python RC, right? So that's the name that I gave it. This is how I'm actually going to run it, right? So these are the commands that I will type up in a sec. Now, usually here, the first thing you're going to specify is you're going to use the keyword from. You use uppercase in the Docker scripts. So from, and then here, all I have to do is specify, for instance, Python. So the version of Python that I want to use. So in this case, Python 3.8. 3.8. You see that? And then also after that, I'm going to specify the file that I'm going to add to this. Okay. And also I'm going to specify, let's say that file needed some specific libraries. So I would install those. So the commands are going to be, from is one of them, then add, then the next one is going to be run, and then finally cmd. So these are the 4 commands that we're going to use to define our Docker container. Okay. So let's go to, let's go to run, for instance. So in run, what do I want? I want to install the dependency. So I'm going to do pip install. Now, I didn't have these in the script, but just imagine that I was using them, okay? So pip install, and then I'm going to install requests. And by the way, these are, these are for this environment. And then there's one used a lot in data science called Beautiful Soup. So this is used for natural language processing and for like HTML kinds of things. So yeah, so those are 2 libraries that I'm basically just installing on this container, okay? Then the next thing that I'm going to set up on this container is actually that file, the file that is in the current working directory. So I'm just going to say main.py, add it to dot, where that means just add it to the current working directory of this container, okay? Because you can have multiple folders within your Docker container. And then finally, in CMD, we use a list, very much like with subprocess, where we specify the commands that should run immediately when you run the Docker command. So in this case, I'm going to run Python, for instance, and then I'm going to say that I want to run the main.py. All right. And so that's basically the idea. So now this is the program that will run. You'll initialize the container, and then this process, this executable should run. So basically we should see hello world when we run this command. All right, so now that we've created, this is the Docker file, remember? So I'm going to go ahead and save it so you can see we've got both files, the main and the Docker file, right, that we need here. And now we're going to proceed to, first of all, build it. So I'm going to do Docker build. And I probably should have given it a different name because I was testing this before. Docker build -t. Oh, actually, I'm going to give it a. I'm going to call it Python RC2. Oh, yeah, sorry. I'm missing the dot. So I have to use that dot to tell it where to put the container in the current working directory, basically, of Docker. So now if I run it, there it is. So it's actually doing it, sending build context to Docker daemon. And you can see it's installing the libraries that I requested. You know, that's just a warning. So, and basically now successfully built. And so we have our Docker container created. You guys see that? Now I'm going to go ahead and do a clear. And now I'm going to run it. So now I need to do, I'm going to do Docker run Python RC2. Okay, so I'm going to go ahead and run that. And there it is. The container ran, and it's basically hello world. Now, this wasn't an interactive process or anything like that. But if it was like a web server, you know, web application, there would be like you can go to localhost or you go to an IP and the port number, basically. And that's it. So that's basically just a quick introduction to Docker and kind of give you the gist of it. Obviously, if you wanted to do something more complex, it's all in here, right? So it's all in here. You can specify the programs, the operating system. You can specify all the files that you're adding or folders. You can specify more things that you're installing, and then you can specify basically what runs initially by default, the very first thing. And then that container is basically up and running, and then you can start interacting with it. All right, that concludes my Docker discussion for today. And so, you know, as I said, I was just going to give you a quick introduction to the topic. Are there any questions about it? Now, keep in mind, there will be questions about this on the exam, right? So just be aware of that. Questions? Make sense? Makes perfect sense. All right, great. So that is, and I'm not seeing any. Oh, there's a question. No question. All right, great. So it sounds like you guys understood. So I'm going to close this now, and we can focus then on the second half. I'm just going to cover the last topic this semester, which is the file system analysis. So you're basically familiar with this. So I'll just kind of like reiterate some of these ideas, and then we're going to go into the, you know, the bonus homework. If you guys want to do it, I'll just do a quick discussion of it. There's really not much to talk about. And basically, there's a few commands that you should be aware of course. So I'm gonna close the VM. I'm gonna leave it open. I might need it. All right, so let's switch over to Brightspace. And I'm gonna share the screen. Wrong window. Wrong window. I'm going to share, yeah, this one. So this is Brightspace. You should all be seeing Brightspace now. We've covered this semester. We've gotten to the end, basically, as you can see. File system analysis is the last topic. There's some slides in here. Make sure you read through them. There's one in particular here called Ethics and IT. Okay, this is a sysadmin class, and that's just purely like a managerial, from a managerial point of view, but please make sure to read through that set of slides. Also, you could have some questions about it on the exam. All right, here is the file system analysis file. So basically what I'm gonna say on the whiteboard, all of it is written here or on this file, okay? So you can just take a look at it, and then we will come back to the the bonus homework. I'll just kind of describe what it is. It's a type of a forensics problem, but it's not really forensics. It's just more from the point of view of Linux, some of the tools that are available in Linux that are open source for that type of work, for instance. So I'll kind of just mention them. And that's the idea. So actually, exam 2 should be here or here. All right, so this is where we are. So let's go to the whiteboard, actually. Let's do that. Go to a new screen. All right, so what is the file system? You've been using it all semester, so you've even used the Hadoop file system, right, at this point. So you're familiar with like a distributed file system, right, and that concept, of virtual type of a file system, and then also the physical file system of Linux. There's really just a few ideas that I'm going to talk about, basically, mounting like devices onto the file system and things like that, right? So it's just fairly quick discussion, but it's the last topic basically for the semester related to Unix. Now that doesn't mean that that's everything about Unix, right? Unix is pretty extensive, in fact, and it just keeps getting more complex. If you notice this semester, we've talked about GitHub, we've talked about Docker, we've talked about, I think, Anaconda, and various other things. So the landscape just keeps getting bigger and bigger, right? Certainly Docker, it's making it much bigger. So the file system analysis. So we're going to talk, just remind ourselves of a few of the basics. Then we're going to talk a little bit about forensics. Basically, that there's something called the Sleuth Kit, and something you can install on Unix and use it for forensic tasks, right? And so what do I mean by that? So what I mean by that is, let's say that you're a sysadmin at a company, right? You work somewhere and a crime was committed on that computer, and it just so happened to be Linux. And then, you get a court order or something like that where they say, we need that to, do a forensic analysis, etc. So basically what the lab document talks about is how you would do exactly that. So let's imagine that they have another computer, right, where they want to take it. So it's going to show you how you can basically open a port, run a specific command in the terminal that will copy bit by bit the entire file system and move it somewhere else, right? And then, they can take it, and basically that's what they can use for their investigation of their crime. You can also, it talks about how you can encrypt it. Obviously, if it were going to the network, right, you want it to be encrypted in some way, but that's just creating an SSH tunnel, so it's not really that big of a deal. All right, anyway, we'll kind of conclude with that, but let's start with the file system just to get acquainted. with it a little bit more. And then after that, just a few commands and then wrap up with this idea of the forensics. So as you know, the file system is basically, all the folders that you have in Linux. Remember that everything pretty much in Linux is a file, including directories. The root directory is basically where the file system begins, the directory tree. I have some really nice slides actually with funny pictures of the file system, so you might want to check those out on the PowerPoint. Okay, they come from your book, so I thought they were nice. So definitely take a look at them, but I'll just kind of briefly go over this idea. So the file system is, it's got the root, and then within it, it's got some. Now, every distro will be a little bit different. Some have these folders, but in general, most of them have these folders. So bin, for instance, is the traditional location. So it's the traditional, all this should be written on your slides. It's the traditional location for executable files. Okay, we talked about how pretty much every time that you type something like ls or a ps or all of those are just basically scripts that have been executables, and then they're placed in this folder. And then remember, you have an environment variable that says, okay, by the way, these are the folders where you should be looking for these specific things, right? So we had that discussion, and hopefully that shouldn't be a mystery to you how that works in Unix, basically. Okay. So this is basically where you have a lot of your utilities in your Unix operating system, or where you have your various commands. Okay, your various commands. Another important folder is the dev folder. All right, this is the device directory. Remember that everything is a file, including your devices. So this is the device directory. Okay, and this is used for such things as disks. Basically the idea of copying, a disk, right? So we're going to take a look at that. Terminals, etc. So that's another folder there that's important. Another important one is etc. So who can tell me what is etc used for in Unix? What is the specific use of the etc folder? What does it store, basically? You've been using etc a lot this semester. Every time you configure something, I bet you went to the etc folder. So what does that tell you about etc? Config files, right? So it's the place where you have your configuration files. Very good. So it's the system configuration files are here. The executables, etc. All this. Remember the SNMP lab, right? Or all of those, right? You have to go in and modify some things. That's the whole point of that, right? It contains also the init.d folder or subdirectory within that. And this folder usually has what are called the system boot files. So you guys know what booting means. So basically, it should give you the idea that whenever the operating system starts, it actually also needs to run a few scripts about its own configuration, networking, firewall rules, and so on, right? So that's going to be in that folder. Then you have the home folder. And this is basically where all the users will have their home directory. So you have /home and then / let's say seed and then desktop and so on. So that's going to be your users' home directories. So all of these can be final exam type questions, right? So just keep that in mind. Okay. And then you have other folders like lib, for instance, which is a location for shared libraries that may be required for booting. Now, one particular folder that we're going to look at today is the mount folder. And this is basically a place to temporarily, so for temporarily mount other file systems. However, in Unix, you don't actually have to do that, like have multiple file systems in a specific place. Keep in mind that this mount is actually just part of the root directory. So technically, there is only one file system in Unix. And so think of it as, you know, like this, and it's got all these places, right? But then maybe over here, you have another file system from let's say this is one PC or one computer, this is another computer. You can literally copy this entire file system, imagine it as a disk, and then just add it to a specific point in the other file system, and then it just becomes part of that tree. So there's only, technically speaking, only one file system, and you can literally add folders, whatever folders you want, or even mount other disks or other file systems to it, and they just become part of the new whole file system. Okay, so that's an important distinction. Another important folder is the proc. This one's a little bit complex to understand, but basically this has some efficiency, this folder. And what happens is, if you remember your operating system classes, is that when you have a Linux operating system, you have what is called the kernel, which is what handles all the functionality with the hardware. And then you have like applications, right, that run on top of this. And this is the Linux environment. However, sometimes there are things like if you do things here, it's going to be slower and less efficient than doing things in the kernel. So that's why, for instance, something like the networking of the operating system will happen in the kernel. It's just got to be faster, more efficient. But let's say that you have a firewall here in the kernel, right? You guys see that? You have a firewall in the kernel. But what happens with firewalls usually? You need to set up rules, right? And the rules might change. So you need to have an efficient way of sending those rules to the kernel, because otherwise, if you had to modify this inside the kernel, then that would mean that you would have to basically compile the kernel every time, right? And that's not efficient. So instead, what you might want to do is the people that design Unix thought of an efficient way of sending data from the outside environment into the kernel, such as firewall rules for a firewall. Do you guys see that? And so the proc folder is exactly for that. Okay, the proc folder is called a process directory. So that's what it stands for. Process directory is designed to enable processes to be manipulated using Unix, what is called the Unix file access system calls. It basically helps to configure processes that are running inside the kernel itself. So it's like a little door in there. Now there's the mechanism that allows you to do that is something called the LKM. I always call it the Linux kernel module, but I think it's the loadable kernel module. And it's basically a specific way of, you can take any software written in C, C++, for instance, and you can just compile it with LKM, and it'll create a type of a file that then you can add to the kernel. And then also here, that file can read data from the outside as long as it's located in the proc folder. Does this make sense, guys? Is this clear? If this was a question on the exam, you'll be able to answer. No? All right. Yes. No, into the kernel itself via LKM. But then this file may still need data from the outside, right? Such as the example that I gave you. Let's say that I want to create my own firewall, right? And I want to connect it to the Linux firewall. So there's a way that I can write it in C, compile it with the Linux kernel module, add it to the kernel. Instead of having to compile the whole kernel, I just add it via this, and it can still talk to the outside via the proc folder, where I can define the rules, for instance, that because they're going to change, right? So I don't want to have to always have to use, compile stuff and add it to the kernel. I just want to like set them up outside. So that's what the proc folder is for. Make sense? Any other questions? Nope. All right. So yeah, so these are some special folders. Some Linux systems have a boot folder for startup related files. So that's another one. All right. So all of you should know this one. If I ask you on the exam, for instance, what is this folder for? What would you say? These are temporary files. How long do files in this folder exist? For how long do they exist, do you think? If you have a file in the temp folder, how long is it going to last? Does it stay permanently there? Lenny? Huh? Yeah. Which is basically the duration of the machine. So it's almost like a RAM. Almost, right? So you unplug it, it goes away, right? So usually you'll see things like when you're logged in, you have special like authentication things that are happening. Usually those files go in the temp folder, okay? There's a user folder. So that contains subdirectories for locally generated programs, executables. So these are basically like for users, something, the distinction between like system-wide programs and then like user-specific programs, right? So they'll go in here. Now there's another important one that I usually like to ask questions about. What is the var folder? What's it used for? Huh? Not variables per se. It's intended for files where the data in them can vary a lot. So what that means is that it can get really large really quickly or very small, right? So spooling things. So for instance, what can go in here? What are things that vary a lot or that generate a lot of data? What's the one thing that's always generating data in Unix? You're always, whenever you run Unix, some data is being recorded. Where does that data go usually? Logs. Yes, exactly. So log files go in here. Also mail goes in here because it's changing a lot, right? So if you have an email server, it's coming in, going. So that's constant. Printing is another one. Another one is the WW. What's that one? When you have Apache, right? And Apache is going to serve your HTML websites. They usually go in, right? This is also a sandbox folder. So the web server cannot access files of the file system, right? It can only access the files in this var WW. Does that make sense, guys? Okay. All right, so that's a few of the folders. Okay. Now let's talk a little bit about a few of the commands. So that was basically kind of a review of the file system and some important folders. Now we'll just talk a little bit about some commands. So let's start with the fact that Unix organizes all user accessible files into a single hierarchical directory structure, right? The file system. The file and directories it contains may be spread across several different disk drives. And really to Linux, that doesn't mean anything, right? It can just be one single file system. So it's in a sense, it's not like Windows. Like if you remember, Windows had the C ... we all remember this format C dot dot or the D drive or the E drive, right? And it's not that Unix doesn't have this, but Unix tries to abstract all of that by basically just mounting whatever's in that drive into a specific point in the file system. Okay, so that's the general idea there. So in Unix, the term mounting a disk refers to the process of making the device's contents available. Okay, just by linking it to a specific point in the file system. Unix will attach the files in the disk to a specific location in the file system of the computer. So if you wanted, so mounting, so that's basically the command that I'm sort of introducing today. There's just like 2 commands. So we're going to talk about the mount command. Now, another relevant command that you probably used this semester is df-h. You guys remember that one? It kind of shows you the file system, right? It shows you the size, like this drive, how much space is, it doesn't have available, that kind of thing. Now, this is for looking at that information. If you want to mount something into the file system, you would use the mount command. And you're just going to say, okay, let's say that I have on my desktop, I have copied the file system from another place. I have that file. So you would just say dev disk 1e, right? So this is a disk, right? And now that exists basically as a really giant file in your computer on the desktop, let's say, or somewhere. But if you want to mount it to the actual file system, then you would just do mount that disk. So this is going to be, let's call it the physical disk partition. To be mounted. Right, and so you're going to say mount the physical disk, and then you just specify where in the file system you want it to go. So for instance, at home or mount or wherever you want it to go, right? That's it. So this part here, we can call it the location where to mount in the file system. Okay, so sometimes referred to as the mount point. And that's literally it. So if you have another Linux file system, like I was giving you the scenario, for instance, you have 2, and I'll do this in the Word document. You have 2 computers, you copy bit by bit everything in that hard drive, you transfer it to this machine somewhere, and now you want to mount it and make it part of that machine's file system, as they're both Linux. You would just do mount that whole partition that you copied, and then you mount it to a mounting point. And that's it. And then now, when you navigate, you can navigate through the entire file system, basically, including the new component here. Now, one funny thing or interesting thing about mounting is you can mount, let's say that let's say that you're going to mount to, test. You can put files in test. Like, let's say you have 3 files in there, and that test is a folder, right? So test is a folder. And in there you have 3 files. And then you say, I'm going to mount this entire physical file system into test. So what's going to happen is those 3 files are going to become hidden. So it's a neat way of hiding something. So you can, you mount it, and now whenever you go to test, what you're going to find is this file system. But the 3 files that you had in there are kind of like in the background somewhere. They're not there anymore. You can't see them. But if you unmounted, guess what? The 3 files are there. So that's kind of an interesting thing about Unix. I mean, I don't know that if people have used it for any specific purpose, but I've always thought that was interesting. All right, so that's basically all of it. Now, the command for transferring data bit by bit from one operating system to another in Linux is the what is called the DD command. We'll see an example of the usage of it in the Word doc, but basically it's a Linux command, and then you just have to say, from machine A, where you run DD, I'm going to copy all the contents, and then I'm going to send them somewhere, right? And that allows you to, so for the type of forensic type of work where you want to copy an entire file system, this is one command that could be used, the DD command. So this is for copying individual disk partitions, basically. This creates a bit for bit identical copy of each file system, including all of the meta information or metadata. Okay. There's a question, it seems. The SCP command that somebody's asking me about is secure FTP. So it's basically a command for sending data encrypted. So if you've ever used FTP, where you send data from, let's say you have an FTP client over here, and then you have an FTP server over there, and you send the data via it. The disadvantage of that is it's not secure. It's not a secure approach. SCP was invented for you to do a secure. I think literally it means secure copy. It's like an SSH, yeah. So everything is pretty much over SSH. Do you have to be in the same network in order for it to work? Not in the same network, as long as there's no firewall in between. I could have a server, let's say on, this is actually how you do it. Let's say you use GoDaddy, right? And for your web hosting environment. So you have a web server at GoDaddy, and let's say the GoDaddy web servers are located in Arizona somewhere in some desert, right? And so you're a developer, and you develop your PHP or whatever on your local machine. Now you're ready to send the files to the var www HTML folder of that IP address in Arizona that GoDaddy has given you. So SCP would be a very nice way of doing this, as long as you have the username and passwords, right? And the keys that will be required for the encrypted connection. But yeah, there's no limit to it. That's actually, that's a use case of SCP actually. Nowadays, GoDaddy provides its own console. So it's much nicer just to use their console because it's GUI. It's a web interface, but it's GUI, and you can just load your files that way. So it's much nicer, but you can for sure. All right, so it seems okay. All right, good. So the last thing we have left today is just kind of to really quickly, just go over that the bonus lab, right? So if any of you want to do it, it's a bonus lab, but you have to solve it on your own. If not, just read through the document, definitely, as you might have questions on the exam. So it's just a use case of like forensics, something like that. So, what is file system analysis? Analyzing the file system, right? So there's really not much that you can do with that. But there might be some files in there that you want to, take a look at. So what I'm going to do now is I'm just going to open up the Brightspace environment under file system. And this is the Word document. So I'm just going to open it. So I'm going to share this screen. So this is very much like what we've been doing all semester, where we basically give you a set of numbers, some bullets, basically numbered bullets, and then you just follow along. So just read through it at least. But the idea is that you have a file system and you're going to copy it from one machine to the other. Okay. Now, one important thing is, if you're literally copying the entire file system of one VM to, say, another VM. So you have to make sure that the VM that's receiving the data has enough space to store the amount of data being sent. That is to say, if the entire file system is 7 gigs, you need to make sure that the receiving VM has 9 gigs, right? You don't want to keep it too close. Do you guys see that? So that's one of the challenges with this one. As I said, that's why I usually don't make it a required lab, because it does have some difficulty there, but it's not really that difficult. So here I provide the commands for checking the size. df-h will provide that. And then here's the mount and unmount commands that I talked about. So basically all you have to do is you have to create a tunnel. So this shows how to establish a tunnel using netcat between 2 VMs. And then you're just going to run the dd command to copy the file system of one VM and send it to a receiving VM over here. So you can see the commands. You guys know pipe now. You understand all of this, right? So you should understand what this command means, basically. But that's basically all it is. Here's a little example. So you have the disk partition, and you're trying to send it somewhere. So you establish a netcat tunnel, and then you send the data. And that's it. So that's the example. So basically, it only involves using netcat df to check the size of both VMs, to send the one that you're copying and the receiving one. Then it includes the netcat commands just to make sure you build a tunnel. And then the third command is just a dd command, which allows you to copy, as we said, bit by bit, the entire file system and send it across the network. Now, obviously, you might want to do that in an encrypted fashion. So that from 28 on is basically repeating the same exercise, but now building an SSH tunnel first. So you can see here now, it's the same idea, but it involves SSH instead of just netcat. The idea would be that if it's something very critical, somebody could tamper with it along the way, something like that. So it's mainly just to try out a few things. And then once you receive the disk partition, basically you would create a folder called victim in your file system, and you just go ahead and mount it, basically. All right, and that's really the idea. So you mount it, and then you can see that here, mount the victim into, victim.sda, which is the thing that you just copied from, right? And then you mount it at this mounting point victim that you just set up. And then after that, you have it available, and they can do the forensics and all of that if they want it. That's the basic idea. A couple of tools that are open source for forensic analysis are the Sleuth Kit and Autopsy. They're basically like web-based. Also, you install it, you set up a server, and then you run that server, a web server, and then you can just say, okay, now look at this thing in mount, or in victim, sorry, and boom, give me some metadata and statistics that are related to forensics. So for instance, it'll give you like any files that were deleted. So the files are still there actually, so it'll show them, and it'll give you metadata about when things were done, etc. So if you, like I said, if you want to do this as a bonus lab, go ahead. Shouldn't be too difficult, but there is some difficulty to it. So, and you can disregard anything related to scripts there. But yeah, this is the last topic. So we've covered file system analysis, did a reminder of the organization of directories in Unix. We also talked about a few new commands that are available in Unix. And then we looked, how to do a little bit of forensics, how that would work. So as I said, you can do this one if you'd like, but it's not required. And then also today we covered Docker. So make sure you review that, and because you might have some questions about it on the exam. There's no homework for it. Obviously we're at the end of the semester now. So that's basically all the contents that I have for today. On Thursday, remember, please, everyone needs to attend class just so I can see before you do your presentations the following week. I want to see your projects where they are. This is, my chance to give you a little bit of feedback, which gives you still, almost a week to make changes for the following presentation. On Tuesday, you will have until Thursday, but you only have those days. So obviously you want to present on Tuesday as much as possible, because if you don't present Tuesday and Thursday, you're going to miss that. And I think project is 10% of your grade. Remember, 5% is the Hadoop problem, and then 5% is just the topic of a Unix system. Yes. Yeah, you can just run. So the reason why I did that lab is actually to give you a task. So you can run that task either with the Python scripts that I gave, or or there are built-in programs in Hadoop. You can just use those. I have a, you'll show me when you run a job that it's actually that both VMs are working on it. Yes. Yeah, exactly. So the work problem, we did it on Linux, but now the idea is that you would run it on the Hadoop cluster, which basically means it's running in parallel. Now, you'll probably say, if I run it in Hadoop and then I compare it to the homework we did, they run at the same speed. So what's the benefit? Well, the benefit would be if you had millions of books, right? Then and in a cluster of many computers, then it would run faster. You guys see that? Anything else? Yeah. Yes, it's comprehensive, and it'll include everything from the beginning of the semester until the present, including the presentations. So anything that's interesting there. So you need to attend the presentations as well. All right, so everyone should be here next week as well. That's it. All right, so we'll stop here for today, and I'll see you guys on Thursday to view your projects. So I'm going to go ahead and stop the recording.